Okay, we are going to be graphing these pictures and then highlighting what are called key features. There are 8 aspects that you need, and there aren't enough colored pencils, so you have 5. You actually need 8 colors, so you're going to have to share with somebody around you. We just didn't have enough colored pencils. Okay. So if you have your calculator, go to y equals, clear out anything that's inside that, and you've graphed before, right? Yeah. So the X button is right next to the green alpha button, and the function that we're going to use is negative 2x squared minus 3x minus 2. Or not negative, just positive. 2x squared minus 3x minus 2. And then you push graph. Did anybody's window not show up like this? Oh, you typed in a negative 2x. I said negative 2x, but I shouldn't have. Yeah, I said negative, and it's not actually negative. Is anybody's window different? Let's say, for instance, that your graph looked kind of funny. Oops. Like this. Okay? That graph's not very useful, right? So if your window is all mixed up, you can push window, and you can actually tell it the lowest x value and the highest x value. So I want to go from negative 10 on the x to 10. And then this SCL is the scale. How often do you want to put a tick mark on that axis? And we probably want to do every one. And then we want to go from negative 10 to 10 on the y. So y min 10, y max 10, and then the scale would be 1. The nice thing is, the calculators understand that this is the most common viewing window. So instead of typing it all in, I can just go to zoom, and then go down to number 6, which is standard. And that's the graph. So whenever your window is mixed up, then you just push zoom 6 and it will fix it. Now, what if I type this in and I get, well, anyway, I'll just put this in there. Let's say I type something in and I get a syntax error. Syntax is just the order that the symbols and the numbers are placed, and it's saying I used a symbol or a number in a place that didn't make any sense. So whenever you see this, click Go To, and it will show you right where the problem is. So hit Enter, and it says that that symbol is wrong. What's wrong with that? It's a subtraction instead of a negative. So if I change it to a negative, it would work. But actually, this graph doesn't have a negative, so I'll just delete it. I'll push graph. So you need to graph this. Get it pretty accurate. Something like that. Now we're going to look at key features. There are 8 key features. Okay? 2 of them are labeled on, well, actually 4 of them are labeled on the axis, and then the other 4 are labeled on the curve. Okay? The first one says domain. What does domain mean? No, nice try. Domain, so if we had a table, which part of that table is the domain? The x value, the left side. So what this is asking is, which x values belong in the table? Well, the calculator has a cool thing. If you push second calc, there's a table. Second graph. So if you had an equation Like if I told you the equation x squared plus 5 and I asked you to fill out a table from 0 to 10, all you have to do is put the equation in your calculator and push second graph, and it will tell you the table. Well, let's look at the table. So look at the x's. Okay, they're in order. I can go all the way back to negative infinity. If I go down, I could go all the way forward to positive infinity. Okay? If you look at the graph, you can see that. Does x equals negative 6 have a point on the graph somewhere? Well, let's look at it. Let's go to negative 6. And it says that negative 6 is the point 88. So negative 6 actually touches the graph way up there somewhere at 88. Okay? What about the numbers in between those whole numbers? Are there y values between x equals 1 and x equals 2? Yes, because this graph is not dotted, it's continuous. Okay? So, are there any x values that miss the graph? So, if I looked at negative 10, is negative 10 going to hit the graph somewhere? Yeah, way up high. What about x equals 0? Does that hit the graph somewhere? Where? Down below. Right here. What about x equals 1? Does that have a graph? So what I'm doing is I have this vertical line, and I'm asking, will this vertical line ever miss the graph? No matter where that line goes, I'm going to hit the graph. So every single x value is accounted for. So take some color, highlight the word domain, and then we are going to draw a line across the x-axis with arrows that go in both directions. So the domain is everything. Okay. Now we're going to look at the range. The range is the set of all y values represented in the function. Are there any y values that do not appear? Where? Good, negative 8 is not there. So if I look at negative 8 right here, and I draw a horizontal line, does negative 8 hit the graphs anywhere? No. And if we look at the table, we can see that. So right now I'm at x equals negative 6, and I'm way up high at 88. And as I go down, those y values get bigger, or smaller, 12, negative 3, negative 2, negative 3, and then what happens? The y values start going back up. What is the lowest y value? Is it going to be exactly negative 3, or could it be a little bit smaller than that? It could be smaller. Could it be bigger? No. But like if I zoom in a little bit and I looked at 1, 2, 3, actually it's between 1 and 2. So if it came down here like this, so it might be a little bit smaller than that point. We won't know, and on Tuesday when you have a calculator, we'll figure out exactly where that occurs. So we know that the y values start at the minimum and go up. Okay? And we need to highlight range. Do you remember the idea of open circles and closed circles? Do you remember when you graphed on number lines? And you had like 3 and you did an open circle and drew an arrow? What did open circle mean? It does not include 3, but everything bigger. What would closed circle mean? 3 and bigger. So when we color these, we need to, if we color the entire line, then we just use arrows on either end. But if we have some sort of beginning, we have to represent it in either an open circle or a closed circle. So I'm going to go all the way down, and then somewhere near 3, is it open or closed? It's closed. So somewhere near 3, well, -3 will have a closed circle and then an arrow on top. So when you label the domain, you color the x-axis. When you label the range, you color the y-axis. All right? Now we want to look at x-intercepts. So pick a new color. I'm going to pick yellow. Oh, how awesome. How many x-intercepts does this have? How many times does the graph actually hit the x-axis? 2. So right here is 1, and right here is 1. Okay. We'll worry about exact next week. So yeah, right now we're just labeling what they are, and then next week we'll figure out what the numbers actually are, which is why you need a calculator. So on Tuesday you have to have a calculator or you won't be able to figure out the exact values. $1 for batteries. Yep. I'll sell you a pack of batteries for $1. Okay. Y-intercepts. There is one y-intercept, and it's right here. There's just one y-intercept. It only crosses the y-axis once. Okay. And the next two are the hardest two. So, whenever you do increasing and decreasing, you're going to imagine yourself driving in a car as we read left to right. So starting at the negative numbers to the positive numbers. So if I'm in a car and I start on the left side and I start driving and I hit this graph, what direction am I going as I follow the graph? I'm decreasing. And then I hit the minimum. Once I hit the minimum, what happens? You start to increase. At the minimum, is the car going up or is the car going down? It's going straight, neither, right? So when we label increasing, is that minimum point part of the increasing set or part of the decreasing set? Neither. So when we label the endpoint, is it going to be open or closed? Well, if it's closed, it's part of the increasing set. If it's open, it's not part. So is that minimum part of the set or not? No. So pick a new color. And at the minimum, I'm going to draw an open circle, and then I'm going to trace the increasing. So the right side of that graph is considered increasing because as we travel from left to right, it is going up. Okay? So decreasing is going to be from the left side to the minimum. Is the minimum decreasing? No, so what kind of circle would we have? Another open circle. Oops. So that's my increasing. Here's my decreasing. Okay. The last two are pretty simple. When is the graph going up? Or sorry, no, we already did that. When is the graph positive? So we're looking at the y values. When are the y values positive? Everything above the x-axis. Those points on the x-axis, are they positive or are they negative? Or neither. 0 is neither positive nor negative. Okay? So, when I look at this left portion of the graph, I'm going to draw a line down. When it hits the axis, is that going to be open or closed? Well, is the x-axis positive? No. So open. Is there another part of the graph that is positive? The right side of the graph is positive. And then where is the graph negative? Is there a part of the graph that's negative? Where? Everywhere below the x-axis. So I'm going to have open circle, and everything underneath is negative. That is a lot of coloring. Okay, I will graph the next equation, and please get a calculator by Tuesday. I would hate for you to fall behind. You really need one, and I know it's after a long break, but you should have had one today. So, so I will graph this, and make sure you do all the coloring, but when you're finished, don't hand this in, because we're actually going to go through and calculate all the numbers. All right, so today we're just coloring. Next week when we come back, we're going to end up calculating the numbers. So I'm going to type in the second equation, negative x squared plus 5x, plus 2. Come on. Okay, there is the graph for the next one. So here is the picture for the third problem. I'll put the fourth problem up in just a minute. Okay, look at the fourth problem. I'll type in the fourth equation and see what the graph looks like. 2x squared minus 7x plus 6. Okay, here is the fourth graph. Now, the fourth graph has something interesting. It goes down and hits the axis and then bounces off. It does not go below the x-axis. So where is this one negative? Nowhere. Where is it positive? Not everywhere. Everywhere except where it hits the x-axis. Okay?